Alright, so today we will be solving with multiplicative inverse how to check your work. Okay, so first we're going to review what we already been working on this week, solving using the multiplicative inverse. And then we're going to have some new information on how to plug in and check your work. So, objective reader, Daniel.
Students will be able to solve equations with a fractional coefficient and plug in answers to check work.
Right. So today, we already know how to solve with the fractional coefficient. We're really focusing on plugging in your answer to check your work. Okay? So, vocabulary, these are review. Jennifer, what is multiplicative inverse?
Two numbers with a product of 1, such as 3/4 and 4/3, are called multiplicative or
Multiplicative?
inverse.
Right. Or reciprocal, right? When you use the multiplicative inverse, you get the product of 1, right? Okay. Coefficient. David, coefficient.
Coefficient, the number factor of a term that contains a variable is called the coefficient.
Right. So it's the numerical part that's attached to a variable. So David, which part of 3x is the coefficient?
3.
Right. This is the number. Numerical means the number, right? Attached to the variable. All right. So good job. Good review, you guys. So right now we're going to review how to solve using the multiplicative inverse. So our problem is -2/7x equals 6. Okay? So what's our first step, Monse? We rewrite the problem. So if you're solving on a separate piece of paper, or you're solving so you can show your work clearly, rewrite it. Step 2, what's our step 2, Angel?
Step 2, multiply both sides by, I can't read this.
By the multiplicative inverse, right? You know the name of this fraction, you should have just said it. Multiplicative inverse, right? All right, so that's what we're showing here. The multiplicative inverse of -2/7 is what? Juan, what is it?
Huh?
The multiplicative inverse of -2/7, what is it?
2/7.
-2/7, what's the multiplicative inverse? I have it written right here on the board.
-7/2?
Yes. So we multiply both sides by -7/2. When you multiply the multiplicative inverse by the original fraction, they cancel out, right? So now we have x by itself. Then we go ahead, what do we do to 6? What do we do to the 6, Daniel?
We multiply.
Yes, we multiplied it, but what do we do first?
We added an invisible 1.
We added an invisible 1 so that this is a fraction, right? So that we can see that we multiply the numerator and the denominator by both. You multiply straight across the numerator, you multiply straight across the denominator, right? So 6 times -7 is what? It's written here. Jennifer.
-42.
Right. 1 times 2?
2.
2, right. So now we have x equals -42/2. But what do we have to do? Daniel. Divide. What are we doing? When we do the division, what is that called? What are we doing to the fraction?
Simplify?
Yes, we are simplifying this fraction, right? Good job, both of you. So 2 goes into 42 21 times. Let's review. 2 goes into 4 2 times. 2 times 4 is
4.
4, right? 4 minus 4 is 0. Then 2 can't go into 0, so we bring down our 2. 2 goes into 2 how many times?
0.
1 time.
4.
2 times 1 is 2. So 2 times 1 is 2. 2 minus 2 is 0. So what's our new answer, Raphael? What does x equal?
21.
X equals 21, okay? So this is review. We've done this all week. So now let's talk about how to check our work, right? Step 1 says to rewrite the original problem. So we're checking if this x equals 21, make this statement true. So you rewrote our original problem. Our step 2 is to plug in the answer for the variable. So, who knows what we're plugging in into this parenthesis? Angel, what are we plugging in?
-7 over 2.
We're
Oh,
plugging
no.
in what we got for x.
Yeah.
So, you want to correct yourself? You want to try again?
No.
Who can help him out? Juan?
X?
Yes, so what are we plugging in for x? So it says we're plugging in the answer for the variable. So this will no longer be x. We're swapping out x for a number. Angel?
Is it a fraction or no?
No, it's not a fraction. Okay, so let's go back. What do we get for x? What do we solve for? What do we get? What number do we get for x?
21.
Right. So if we're swapping out, since we have a value for x, this is no longer going to be a variable. We're going to put that value that we got for x in x's place. Okay? So what number is going into the parentheses? Jennifer?
21.
Yes, 21 is going to go into this parentheses. Because that's what we solved for. That's how we got x. Right?
Yeah.
Okay, so step 3. Any questions so far?
Hmm.
Who thinks they know what step 3 is? Once you plug it in, what are we gonna do next? Daniel?
Multiply across it.
Yes, we're gonna multiply going straight across, right?
Mhm.
So you guys know when these two things are really close together, there's no symbol in the middle, this means to multiply, right? This is showing that we're multiplying. So you solve by multiplying straight across. So what would that look like? I'm looking for new hands. So Jose, if we're multiplying -2 over 7 times 21, how do we make these both look like fractions? Jose, I need you to look up here, please. How do we make these both look like fractions? So what did we do here? Let's look at this section. 6 didn't start off as a fraction. What do we do to make 6 look like a fraction? Hands down. So Jose, you see this 6 here, right? It did not start off as a fraction. But now we have a fraction right here. We have 6 over 1. So what do we have to do to this 21 to make it a fraction like we did the 6? What did I do?
You have to multiply.
Who can help him out?
Divide.
Monte. You add a 1, right? You put 21 over 1 so that they look like a fraction together. So -2 over 7 times 21 over 1. Okay? Right?
Mhm.
Okay? So now we can go ahead and multiply straight across. What's 21 times 2?
20.
21 times 2.
42.
42, right? Think about it, you have two $20 bills.
Negative.
It's okay if you have two $20 bills, you got $40. But there's still $2 left over, 42. That's a quick way to think about it, okay? So it has to be a -42 because we have this negative sign, right? -42. What's 7 times 1? 7, right? What is our final step? What do we have to do?
Divide.
Divide. But what is that called? When we divide, what is that called? Simplifying, right? Make sure you raise your hand. That's what you're gonna say, Daniel?
Yeah.
Okay, good. So step 4, simplify. So now we're dividing 7 into -42. How many times does 7 go into 42?
6.
6 times, because 6 times 7 is what?
42.
Right. Okay, so do those check out? Does 6 equal 6?
Yes. Yeah.
Okay, good. So that's how you check your work. You solve it out, then you plug it back in. Okay?
Okay.
Alright, good job.